everyone. My name is Brianna Curl, and I will be your moderator for today's webinar on CADsync for SolidWorks, Bridging the Gap Between Electrical and Mechanical. If you have any questions throughout the webinar, please type them in the questions panel as they come up. We will have representatives ready to answer your questions directly during the webinar. This webinar will be recorded. The recording and the presentation slides will be posted on the EMA resource page. With that being said, I want to thank you all for joining us for today's webinar and introduce you to our presenter, Sue Frederick. Sue has worked with the Cadence tools for over 25 years, both as a PCB designer and application engineer. Prior to joining EMA, she worked in post-sales customer support at Cadence, focusing on the front-to-back OrCAD, Allegro, and PCB SI flows. Assuming we have time at the end, we will field some questions in a Q&A. Thank you for your attention, and now over to you, Sue.
Thank you, Brianna. Hello, everyone. Thanks for joining us today. During today's webinar, I want to cover the following topics: common challenges without an integrated ECAD-MCAD flow, the benefits that CADsync can offer your design teams, what CADsync in SolidWorks looks like. Then we'll go into a demo with the Q&A following shortly after. To begin, I'd like to go over some common challenges that companies may face when there is no integrated flow. Since most companies don't have an integrated flow, how's information passed back and forth? When the ECAD and MCAD design flows are treated separately, often there's a lack of communication or even miscommunication, which can lead to design issues. For example, if both teams are designing to larger tolerances, the whole project can be over-margined, leading to increased costs and possibly a larger assembly than needed. There can also be issues when the teams are not working with the most up-to-date files, so parts and mounting holes may end up in the wrong locations, or sometimes the board outline doesn't even fit within the mechanical closure. This is problematic when trying to meet project deadlines. One or both design teams may need to go back to the drawing board. An additional 2 to 8 weeks for a new PCB or enclosure can ultimately make or break your product. Another challenge that designers may experience is deciding who owns the libraries and who is responsible for managing and syncing parts. If there's no clear communication between the teams, this can lead to a delay in updating parts. Without an easy and quick way to share design files between the teams, bug fixes within the design may be delayed. Another side effect of this is the opportunity for the two teams to become dissociated, leading to the design going down two different paths. Meeting project due dates becomes very difficult when these situations happen. Finally, the lack of accurate 3D models is another challenge you may have. The inability to get an accurate 3D model from the ECAD teams causes the MCAD team to spend a lot of time creating 3D parts from the 2D drawings that were imported. CADsync offers a native ECAD-MCAD bidirectional interface, which allows the two teams to quickly and easily manage and sync parts, improving overall productivity. With CADsync, there's no need for clunky middleware or the need to schedule meetings and pass emails. The bidirectional interface supports keep-ins, keep-outs, copper features, including copper areas, silk screens, and assembly layers. You can leverage the CAD data within your tool to send updates and keep everybody in sync to prevent integration errors with the native file structures. With traceable collaboration, it's now easy to track design change history. This helps ensure the design intent is communicated correctly. CADsync helps the MCAD team collaborate with the ECAD team by communicating mechanical requirements and managing common elements such as mounting holes and board outlines. CADsync provides the ability to create new SolidWorks parts from step models that are attached to parts in PCB Editor. This can be a huge time saver for the MCAD team. It also prevents mechanical engineers from receiving step models or 2D drawings that are inaccurate and slow to load. SolidWorks can import ECAD objects as solid features into the design. Leveraging the PCB data as SolidWorks parts, features, and assemblies allows the ME to treat these as they would any other solid model. The pads and traces are imported as extrusions with copper thickness from the surface layers of the PCB. This feature also sets the design up for simulation, since the electrical elements are put into context, leading to the most reliable path to production. SolidWorks versions 2017 through 2020 are supported by CADsync. CADsync uses a collaboration area that can be accessed by the ECAD and MCAD teams. The CADsync proprietary files are read from and written into this collaboration project folder. During collaboration, comments can be added to the incremental change files that are sent back and forth between the two teams. Special CADsync menus and integrated icons are incorporated into SolidWorks. These allow for easy navigation and editing. CADsync can take a step model and generate a 3D SolidWorks part from the PCB editor footprint. This SolidWorks part can then be added to the PDM flow. This allows for the ability to include data managed parts. With native solid modeling, the ME can view, inspect, and modify the imported parts within SolidWorks. This feature helps with implementing new design changes and fixing design errors much faster than alternative methods, such as sending DXF files. Placement heights for parts and regions are supported within the CADsync flow. If a part is placed in a height-restricted area, the PCB designer will be notified of the error in PCB Editor. The PCB tools utilities allow users to start their design intuitively, then easily add the ECAD features to components, cutouts, mounting holes, keep-ins and keep-outs, and copper areas within SolidWorks. For example, the creation of keep-ins and keep-outs are automatic and imported as transparent extrusions which allow for easy viewing and can be suppressed if needed. The feature tree is used to organize and manipulate the PCB features. The available features can be filtered by keep-in or keep-out type, hole size and type, or component ref des and part name. So now I want to show you just the interface of CADsync between SolidWorks and PCB Editor. What I have here in SolidWorks is an enclosure with another assembly inside of it. So in here, I'll just go ahead and suppress this the top of the enclosure so you can see what's inside. So I have another assembly in here that we're going to use as a board outline that will pass over to PCB Editor. And in here, I can put in features for the PCB. So at this time, I can check the parts in the assembly. We see we have a PCB, but there's nothing associated with the PCB in this assembly. So what I want to do is go into this board outline part and add these features in so that PCB Editor knows what each of these features is when it comes over. So as you can see here in the feature tree, right now I only have a couple of extrudes and a cut extrude. So I can use the CADsync menus at the top to assign PCB features to this part. Right now, the first thing I'll do is just show the part features. So this is going to show what features are currently set up in the part. So right now, we have no PCB features in here, so it needs to be set up. The first thing I need to do is assign one of these extrudes as the board outline. To do that, I can use the Assign PCB Outline icon. And in here, it says Board Outline. I'm going to use Extrude 1 as that board outline. And now if you look at the feature tree, you can see there's a board outline over here with Board Outline Sketch under it. So it's no longer listed as an extrude. The next thing I can do is assign hole features to these cut extrudes. I have the option of assigning plated or non-plated mounting holes. I'm just going to select non-plated. And then this last extrude could be assigned as a place keep in or keep out, or a route keep in or keep out. But to assign a feature here, we can assign the outline features. Now it's selecting extrude 2, and I can choose what I want this extrude to be. I'm going to make this a place keep out in the PCB. And looking at this from the side, you can see that there's actually an offset from the board. So this allows you to send over minimum and maximum height restrictions to the PCB designer. So if I go ahead and save this and bring up the assembly again, you can now see that this assembly has all the PCB features that it needs to go over into PCB Editor. I can do a check assembly here, and before we had seen nothing. Now we have a board outline, and there are holes in here and a place keep out. So this is set up to go over into PCB Editor. So at this point, what I can do is export the assembly. And what this is doing is it's going into an area that I have set up, a collaboration area where both the ECAD and MCAD teams can access. And it's going to write this baseline file out. So this is the file that it's starting with that will be imported into PCB Editor. So I'm going to go ahead and export the assembly. So what this did was it wrote out a file, an EMZS file, into my collaboration directory that I had set up. At this point, I can go into PCB Editor and import that file. So we have an export from SOLIDWORKS and an import into PCB Editor. So using the CAD Sync menu here, I can select Import. It goes into my collaboration directory that's already set up. I can click on the baseline file. And these are the different features that were added in CAD Sync in SOLIDWORKS. So you see I have a board outline, the drilled holes. If I select each one of these, it's going to show a preview of them in the canvas. So if I zoom out, this is everything that was defined over in SOLIDWORKS. I can say OK, and that just imported my baseline into PCB Editor. And looking in here, I do have a package keep out on the top that I set up, and then the design outline. So everything came in on the layers that were required. Now this board already has a netlist in it. So what I want to do is bring in one of my parts. So I can bring it in here and then just rotate it. I'm going to place it into this, the place keep out area. You can see there is an error here. So that place keep out did come over into PCB Editor that you had set up in SOLIDWORKS. So I'm going to go ahead and just move the part out of that area since it is a keep out area. And I also want to add a route keep out shape and pass it back to SOLIDWORKS. So I'm just going to put a rectangle on the top layer. So now I have a couple of changes that were made. I added a part and I added a route keep out. So I need to get this back into SOLIDWORKS. I can do this using collaboration. At this point, once you have exported from SOLIDWORKS and imported into PCB Editor, you're in a collaboration mode where only the changes are going back and forth between the tools. So I'm going to push the updates, and then I can tell it which changes I might want to send over into SOLIDWORKS. There is a board outline change here, which is just the thickness of the stack up in here doesn't match the thickness of the board in SOLIDWORKS. I'm not going to resolve that right now. But I do want to send over the placement of P3 and the route keep out that I added. So I can click OK. It's going to write out, it wrote out a file to my collaboration directory. Now it waits, it's waiting for a response from SOLIDWORKS. So it pings the directory and it's just waiting to see if there's a response file from SOLIDWORKS. Right now it's not seeing anything, so it's saying no MCAD data available. So I'm going to go back over into SOLIDWORKS, and I need to bring these changes into SOLIDWORKS. And to do that, once again, I need to use collaboration. So on the SOLIDWORKS side, the two modes for collaboration are to PCB and from PCB. Since I want to bring changes in from the PCB, I'm in from PCB mode. And I can select which changes I actually want to bring into the board file here. But let's say I want to accept the component that was added, but I don't really need the route keep out. So I am going to uncheck this, and that's going to reject the change. I can put a comment in here that I don't need the route keep out, for example. And then once I have everything in here, I can just say pull changes from the PCB. Now what it's doing is it's looking for this part, this SOLIDWORKS part, for the component that was added in PCB Editor. It did not find it in a library, so what it did was it created this part on the fly based on the step model that was assigned in PCB Editor. So this part was just generated by CAD Sync and placed on the board as you watched it right here. So this is a great way to get your parts into SOLIDWORKS from PCB Editor using the step models. Now looking down here at the status line, you can see a response was generated. So this is the response file that PCB Editor is expecting to see so it knows what has been accepted and what has changed. I'm not going to process that just yet. So what I want to do is just move this component. So I might want to move it closer to where it actually belongs in the enclosure. And once I've moved it, I need to send this back over into PCB Editor. To do that, we're still in collaboration mode. So at this point, I want to go to PCB. And the only thing that I've changed is that I moved P3. So I'm going to select that and say push changes to PCB. Now it wrote out an increment file. So these are the incremental changes that are being added into PCB Editor. Then coming back to PCB Editor, I'm going to refresh this form. By refreshing this, it's gone back out to my collaboration directory and said, oh, I have a couple files there I need to process. So there's a response file and an incremental file. I'm going to pull the updates, and here you can see which file to import. I'm going to process the response first so that I know what the mechanical engineer has accepted. So doing this, I see, oh, my route keep out was rejected. I'm going to go ahead and say, just check both of these, say OK. And then that route keep out was removed from the board. So that rejected change got processed by PCB Editor, and now the boards are, the response was processed. But there's still some information that's out there that PCB Editor needs to bring in. So I'm going to go ahead and pull the updates. And here's the movement of P3. So if I select it, you'll see a preview where it's showing where that part has been moved to. I'll say OK, and it's accepted that change, and now everything is green again. So we're in sync. The board is in sync with SolidWorks, and we're OK to go on with things. And this is really the process that you're going to use between the two tools. Once you export from SolidWorks and import into Allegro, you're in your collaboration mode, and changes are being written out to your collaboration directory for the two different tools to process the responses and the incremental changes. So that's the flow between the two tools. Back to you, Brianna.
Thank you, Sue. And at this time, I would like to open the floor up for the Q&A. So please enter any questions you have into the chat now. If we are unable to address your questions immediately, we will be in contact with you and follow up with you individually. So for our first question, Sue, can you go over the versions of SolidWorks that are supported with CADsync again?
Yes, SolidWorks 2017 and above are supported with CADsync.
Okay, thank you. Let's see. Does this require CircuitWorks?
No, this connects directly to SolidWorks. CircuitWorks is not needed in the flow with CADsync.
Does this work with both OrCAD and Allegro?
Yes, it works with all tiers of PCB Editor.
What features are supported in CADsync?
The features that can be imported and exported are parts, holes, board outlines, keep-ins, keep-outs, and copper area shapes. Pads and traces can only be imported from PCB Editor but can't be exported. Part heights are also recognized within the CADsync flow. Any placement height errors will be flagged in PCB Editor.
Okay, thank you. So what happens if I already have parts for some of my components in SolidWorks?
CADsync looks to see if there's any matching parts in your library before creating a new one.
Okay. Our next question is, could I use the SolidWorks offset command to define the board outline sketch from a space or an edge in the PCB housing?
Yes, you can. The offset command would be a good way to define the board outline sketch.
Okay, thank you. Let's see what else we have. Can we use SolidWorks parts we already have in our parts library to build the PCB assembly?
Absolutely. The SolidWorks part needs to be built in the XY plane and have the same default rotation as the ECAD footprint. If it doesn't, you can add a coordinate system to align them. CADSync finds the coordinate system and places the part such that it matches the footprint.
Okay. Currently, our MCAD users receive a steps file from ECAD and open that in the product assembly to do interference checks. What is wrong with this approach?
So there are some things to consider here. An assembly created from a step model is slow to work with and can't be edited easily. The CADSync approach allows you to start the design in SolidWorks, avoiding errors normally introduced by reading a drawing or importing DXF to create the board profile, locate mounting holes, and position critical components. By using collaboration, both ECAD and MCAD have effectively the same data, even though they're using different tools.
Okay, thank you. The parts in our MCAD library are named using the component part number and have no relationship to the PCB editor footprint name. How can we relate the footprint to the SolidWorks part name?
CADSync offers a few solutions to this. If your PCB editor component uses your company part number, there's an option to use the part number as the SolidWorks part name. CADSync also provides a way to use a mapping file to relate the footprint name to the SolidWorks part name.
Let's see. We use SolidWorks parts with a configuration for our SO, SOL, VGAs, and other components that have the same body, just a different number of pins. Can CADSync use these parts with the configuration?
Yeah, it can. The mapping file option has a way to relate a footprint name to a part name and configuration name.
And when I start the PCB design in SolidWorks, can I assign a reference designator and part numbers to the parts I place?
Yes, you can do this using the PCB tools utilities in CADSync.
It looks like we do have some more questions, but we're going to wrap the rest of this webinar up. If we did not get to your questions, we will be following up with you individually. And I'd like to thank you all. And if you have further questions, you could always email us at info@ema-eda.com. We'll be sending a recorded version of today's webinar with the slide deck within the next few days, so keep your eye out for that. And before we sign off, I'd like to inform you of our next webinar on transitioning from PADS to ORCAD. And I want to thank you all for joining us today, and thank you, Sue.
Okay, thank you.